Good morning, good afternoon, or good evening, depending on where you're joining us from today, and welcome to this Agile Business Webcast Series broadcast. 3 reasons your automated test isn't automatic and how to fix it. This webcast is brought to you by Steam Crossroads and Agile Journal and is sponsored by ElectricCloud. I'm Patrick Egan, publisher of the Agile Journal, and I'll be your moderator today for this webcast. Well, in a few moments, Martin Van Rysek will join us to discuss how automated system test harnesses have evolved. But first, let me take care of a few housekeeping details. This new livecast webcasting environment is intended to be completely interactive, so you'll have the ability to post a question at any time by using the chat box that you can see down below the webcast screen. You'll also notice there's a pop-out button down at the bottom right corner there. That'll let you actually undock the chat box from the screen so that it doesn't get hidden behind the slides if you want to expand the slides later on as well too. Also, if you'd like to share your thoughts and follow along by Twitter and Facebook, go ahead and use the Twitter and Facebook links up there above the screen. And don't forget to use the Agile LC hashtag in your tweets so that you can see your tweets in tweet roll on the right side of the screen as well too. Also want to mention, if you want a copy of today's presentation, you can click on the Resources tab over on the right side of the screen there, and you'll be able to download a copy of today's presentation in PowerPoint format. Also, if you ever need to get a closer look at any slide, you can just mouse over the screen where the slide is being presented and click on the full button. It'll expand to the full size of your browser window. Also, a complete recording of today's presentation, including the Q&A, will be available by tomorrow at the same link. So just come on back here again if you want to watch it again or recommend it to a friend. Well, let me introduce our speakers today. Martin Van Rysek is the Vice President of Engineering for ElectricCloud. And he brings us over 18 years of experience in building commercial enterprise software and has a BS degree in computer science from the University of California, Davis. Well, Martin, I think people would much rather hear you speak than me. So if you're ready to go, the floor is yours.
Thank you, Patrick. Thank you, everybody, for joining. I appreciate you spending the time with us wherever you are today. Today we're going to talk about the title of the presentation is 3 Reasons Your Automated Test Isn't and How to Fix It. And we can stimulate some thinking and perhaps give you some pointers of how to improve and work on automated testing or get it going if you haven't started yet. Today I'm going to talk about first the ideal world. What if we could wave our magic wand, would we do? What do we actually get usually in the real world? What's causing the difference between those two? And some things we think you can do to solve that. So let's talk about what do we want, the ideal world. Well, saying you're going to automate tests or system tests is a loaded statement because there are a zillion kinds of tests. And so I'm going to concentrate on one particular type of test. I'm going to talk about system tests. So these are tests, unlike unit tests, which are usually isolated, run as part of the build, maybe the QA team isn't as involved. System tests, typically the QA team is involved. That's not necessarily always the case. What we like to see at ElectricCloud is when automated system tests are part of a automated framework that both QA and dev work on together. I think that's the best value. But the main point here is QA is also involved in system tests. Usually more black box than white box. A lot of times the harness is very custom. Everybody's applications are a little bit different. A lot of homegrown invocations. There are frameworks out there and system test frameworks from commercial vendors that folks also use. We mostly see kind of complex custom harnesses in our customer base. And the kind of the time frame of when you're going to run this is usually longer running tests. This is a lot of complicated end-to-end kind of testing, and it's usually not run every build, every cycle. It's usually run near the end as kind of a validation, and that's one of the things I think is a problem. We're going to talk about that. And folks who are doing system tests usually have invested quite a bit in them, and so the maturity of them is quite high. Although certainly we're going to have people on the phone today who this is the first time and they're trying to figure out how to do system tests. So we'll talk about that too. So I'm going to use, although we're talking about software, it's easier to show a picture of a device. So I'm going to have the mythical calculator, but imagine this is a software piece that does the same function as a calculator, and we're going to do some system tests on it. So that's setting the stage for what we're talking about. So what is system test in general? Well, let's talk about what it's not. So is it a hunt for evil? So think of all the people in the line at security at an airport are all different builds or jobs. And when I think about this in a software environment, I'm thinking about everything from building and compiling software to automating the test. So let's talk about this as an automated test run. Each one of these people represents an automated test run. Are we really just looking for the one that was bad? 15 went by, 14 were good, 1 was bad, kick it out of line? Not really. The opposite of this, is are we looking for goodness? Are we looking at 15 and trying to pick the winner? Right? 14 are going to be bad, 1's the winner. It's a audition, it's a talent contest. What's the best build I can find? Not really either of those. Both of those are what we like to call stream filters. Right? They are, I'm looking at a stream of things, of many things, and I'm trying to pick a bad or a good one. That's not what system test should be. A lot of people have the model in their brain that that's what system test is. And that's something we really don't think. I like to think of it more as a meter. Speedometer, GPS, thermometer, whatever you want to call it, a dial, a gauge. It doesn't have a yes or no answer to it. This book by Jim McCarthy, which I really like, he has a quote in it which I think explains the concept very well, which is, if QA feels its charter is to test the product that development has created, or vice versa, development is convinced that its job is to create a product that QA tests, then some alarm bells should go off in your head. That's not really it. The job of system test, particularly of QA with system test, should be to continually assess the state of the product. This is very agile thinking, right? This is not waterfall. This isn't throw it over the transom and now test it. In most shops today, everyone is going to agile software development processes. This is the agile part of system test. The system test should be constantly looking every day, every hour if you can, what is the current state of the product? And that is on many different axes. So absolutely, there are parts of system tests that are looking for pass-fail. So although we said it's not a hunt for evil, within system tests you are looking for individual little evils. But that's not the whole story. There's also many numeric ranges you're looking for. What's the performance? What is it? The time to load a value? How many changes have occurred since the last build? You're looking at risk metrics, things like that. There's all sorts of things that an automated system test should be looking at. And what's really important is what is my last baseline? What's my change over time? Are we getting better? Has anything drastically changed? Someone checked something in that messed up the schema or the indexes on the database, and now suddenly all the queries are taking much longer. You might not have an absolute value of what is the proper amount of time, but what you've detected is there's a huge change. That's very valuable. There are things that you do want to have absolute values for. How long does this? Am I within the range or not? The percent of requirements are complete. That has nothing to do with performance at all. If you have broken up your software into stories and requirements, and you want to know how far are we to completing the product, that's another thing system tests can help you with, because you should be, if in a test-driven methodology, you should already know all the tests that need to run for the finished product, and you can watch as they get filled in. The world of system tests, I probably don't even have all the types of system tests here, are all the different kind of things you can measure. There are many different end-to-end things, from compatibility, error handling, load, does the install work, does recovery work, does failover work. All of these things are all the many different types of things that system test might encompass. And within that, in our ideal world, what we want is we need a frequency of how often we're going to test, and we're going to want to know how detailed in each one of those segments, or which segments we're going to cover, what are we going to actually measure. And in an ideal world, I want more of either of those, I should just be able to add tests and servers to support running those tests, and I should just be able to keep heaping on more and more tests, more and more servers until I hit the ideal condition where I've tested everything. We know that that's not reality, right? So even though this section is entitled, What Do I Wish I Could Do?, I know enough to know that I'm never going to have 100%. I would love to say I'm just going to increase the frequency and the detail, and I'm going to catch more bugs earlier, and no customer will ever be impacted, and everything's going to be easy. Real world, the return on investment for automated tests is not quite that linear, that as you put in more effort, you get more value. You hit some walls where at a certain point it just doesn't make sense to automate anymore because you're just not finding more things. You're putting way too much effort in for that last bit of coverage where maybe some manual testing could cover it. But there is an ROI and there is a slope. It's just at a certain point you hit the wall. So why doesn't testing work? And this is based on our experience talking to hundreds and hundreds of customers who are doing automated test frameworks with our products and other products here at Electric Cloud, and what we've picked up from our customers. So let's go through some of what we've observed. So one of the customers we've talked to, a large customer, they make database adapters, their problem was a large test matrix, lots of combinations of databases and OSs and versions that they had to test. Lots of developers, geographically distributed. Unit tests were done with the build, and they had a large automated functional test, which was a good thing, but they had some problems. And the problem was when we talked to them from the top management, they still said, even though we've got this great automated test framework, our product quality isn't showing it. We're still finding bugs caught too late. Development still seems to not be working as fast as we wish the whole process could be, and they're questioning the value of their automated tests. Talking a little further to some of the folks involved, they said, okay, so here's some of the problems. There's no way to run smoke tests on a continuous integration build. Smoke tests being, okay, QA might have their full test suite that they're going to run, but every build that comes out of a continuous integration build, we would like to run some subset of that. That subset we'll call the smoke test. What are the smallest subset of tests that validate that this build isn't completely broken, that is worth doing further testing on? There was no way for development to actually initiate any of those tests without having to ask QA, Mother may I or Mother will you please run those tests. So the automated tests, although for the QA group, when they went and manually pushed a button, some things happened automatically after that. When you really looked at it, it was not automated end to end, and it wasn't available to everybody to run automatic. And the tests themselves were just too hard to run and too hard to get the results back. So when we looked at it, well, why is that the case? They said, well, okay, when we want to run one of these automatic tests, actually you had to manually provision the resource you were going to run the tests on. So that was number one. You had to install the product by hand. So you had to actually do an install of the product. You got the bits that were built, some installer executable, but someone then had to install that on the resource that was just manually provisioned. And then when it was time to run the automated test, you started some script that had lots of options that you had to fill in. That was also manual, launching that. And then all the results would come streaming by in log files and on the screen, and you had to kind of manually watch that and dig through it to find out what happened. And so if something did go wrong, trying to find out that something went wrong or reproduce that, you would have to go through all those manual steps again. So what they found when we really examined it was that they had parts of tests were automated, but really because the whole end-to-end wasn't automated, it was more of an impediment than an enabler because people were spending a lot of time trying to get tests in, which put a big burden on the value those tests had to have if there was such a big burden into running them. And so that it wasn't giving them the results they wanted. What their mental model was I would really like to have one person say, hey, ding, I want to run these tests. So magic happens, and you get the test results. What that meant was I really want to run one click and have that happen. In reality, what happened was I want to run these tests, and then you had to sit and watch the pseudo-automated tests. And it was kind of the babysitting role where there were very busy, very expensive people sitting watching automation run and babysitting it. And so the solution was, can we get rid of that babysitting? Can we really make this automated end to end? And so that's an example of from one customer how that happened. So let me go back to our calculator example, and I'm going to flip through a bunch of slides very quickly here. There's kind of three components to it that we found, and this was the three components we're going to talk about how you can fix. One is you have automation of the test harness. So you have a bunch of inputs, and you want to send different sets of inputs to an automation harness. So you've got to have that automation harness, and now you're going to run it, and it's going to automatically drive your product and drive those inputs into the product, and it's going to look for the output, and it's going to do some sort of a compare and say, what's that expected? And that has to come back in some sort of a report. And this is what the customer had. I had to, in their mental model, this is the automation they had. But if we look at what was really happening, this test environment on a resource had to be set up, and therefore picking one of many instances or maybe 0 instances of that product. Maybe I had to install that instance of that product myself before I could even get going, or had to kind of manually pick from an existing staged environment of where I was going to run it. The test harness running was automated. It would, once you got it going, it would actually run it, put the values in, and get the result. But the results ended up just, like I said, in a text file somewhere. So if you kind of decompose it of the different 3 big pieces that they had, they were all human intervention at each one of these steps. So the resource management, and I mean actually provisioning or selecting a pre-provisioned environment, was manual. The harness automation, yeah, the harness, once it got going, would do its thing. That's not really automation if you still have to have an operator pushing all the buttons to get that automation to go. It's kind of like driving a car, I guess. An automatic transmission versus a manual transmission. Yeah, both work, both can drive. A manual transmission certainly is pretty cool that you can have different gears, but you still have an operator trying to tell the car exactly which gear to go into at what point and what time it makes sense and if I should downshift or not. Whereas an automatic transmission just makes all those inputs for you. You just give it the higher limit and it's going to go fast. It takes care of everything else. That's really what we're talking about here, that there is some that's automated, but it's not enough. And the results processing are manual. Someone has to comb through it. There's no big, red button that says something went wrong, or here are the gauges. Here's the values. I'm going to present the data for you in a consumable way from gigabytes of log files. So those are the 3 areas. Just to repeat them: resource management, harness automation, and results processing. So how do we fix that? Let's look at this. So this is an evolution. These are problems that have been solved before, and if we look at this evolution, you might recognize this. If you've been doing things as long as I have, you'll find where you kind of entered the software development world. I don't have a timeline here, but we could probably put one on there. There was a time when everything was binary programming, right? It's all assembly language. All binary programming. Okay, then said, okay, well, we need something more sophisticated than a software development environment. We can't just be writing binary. So then assembler came out. Okay, much better. It's a little more human. No, that's not good enough. We need a compiler that can build assembly, that puts it more in a human language. Okay, that's great. Now we can write our code in a language that's a little more easy for humans to understand, and then have technology translate into what a computer can understand. But now I have lots of programs, and I have lots of source code, and I need to organize that. So, okay, I need a make file. The make file is going to let me put some rules together about how to assemble and drive that compiler and tell that compiler when it should run. Great, except now I've got an even more sophisticated environment, and I've got multiple components, each with their own make files, and they're in different subdirectories, and I've componentized my software, and it's gotten even more complex. I need another layer on top of that. I need a script, a build script that will kind of decide what make files and go into different directories and what I should do, automate as much as I can of one run of a build of this software. Great, that's nice, but then another maturity model came along and said, yeah, I need to run that build script something needs to run it automatically. And what's that? That's continuous integration. I want when someone checks in code or some external event happens or on a regular basis, if I have a nightly build, something has to be the automation piece that runs that build script, right? And so we've gone through this evolution as an industry. And what we need to do to really automate tests and system tests is to continue that evolution. So a lot of customers have custom or third-party harnesses that they've built on top of the system test. And as I was saying before, that's good. It automates some things, but it doesn't give us that end-to-end. What we really need is something on top of that, which is a workflow automation engine that's going to drive the harness, not only the harness, but also knows something about resources, knows something about communication, knows something about data synthesis, knows something about creating reports, pulling interesting bits of data out. Something that can do all three of those tasks for me, do the resource piece, drive the harness, get the results, and bring that back to me in a consumable, easy way. Something that you don't have to be an expert to click that button. I want anybody to be able to now drive that. Just like if you look at makefiles for very large software projects, a lot of the customers we talk to are afraid to touch some of the makefiles. They've been around for many years. The people who wrote them are gone. Same with the build scripts. They do what they have to do, but it's kind of a black magic. And a lot of people aren't real clear about what's going on inside of it. But they know how to run it. Yeah, I type make, and it makes it. And it's always worked, and until it breaks and someone has to dig in and figure out why it doesn't work, I'm fine with that. You need that same level of confidence on the system test. I don't have to have much information or knowledge about how things are organized or what machines are available or what IP addresses are or what data center it's in if you're really large. I just want to be able to run my test. I want to request that this test run runs, and I want it to happen on a regular basis. So let's get that next level of sophistication. So in order to maximize this, just to repeat, manage resources is important. Let the system, this automation framework, should be finding the resources for you. It should be allocating them for you. It should be making sure nobody else is running on them. It should make sure it's clean. It should take care of the resource management part of this. Driving that harness, passing in parameters, passing in subsets of tests that need to run, allowing folks to have that exposed in a very simple, even drop-down menu sort of way of what do I want to run, should all be part of just one click and go. I should be able to get those results back, and really for my ideal, if I have 15 people who want to run the system test at the same time, and I have enough resources, and with virtualization and other technologies, there's really no reason even a small shop shouldn't have the resources, then I should be able to run that as much as I want. I should just be able to scale that. And I should be able to scale the number of machines I need if one of my harnesses needs lots of machines. Let's say I'm doing performance tests or something like that. So let's look at this in a little more detail. So what do I mean by this resource management piece? So some things that I wish I have. One-click login to 20 different systems. So yeah, it's a complicated environment. Maybe I have database servers, agent servers. Maybe I need many different variants. I should just be able to come into one system and have it know about all of that. If I have multiple tests that need to run in, maybe they're even different test frameworks, I want them to run on the same machine or the same resource or the same configuration, I should be able to do that. I should be able to figure out how I queue them, how I synchronize, how I organize multiple things going to those same resources. I should be able to select systems pretty easily that have the desired configuration. Maybe it's the operating system. Maybe it's the version of my software that's on it. Maybe it's, for instance, here when we test ElectricCommander are one of our products that is the automation framework that we're talking about. When we test it internally here, it has to run on many different operating systems. It runs on several different databases, and then we have different versions and patch versions, and that matrix gets very large, very fast, even for a small software company. You have to. I would like you to be able to actually create machines on demand for that test. Don't just go to an existing environment. Be able to talk to the APIs of the virtual machine layer and say, I want a new configuration, virtual machine configuration of type X, and I need 10 of them right now. Make them so. Well, the harness should be able to do that for you. And it should be able to schedule devices, test directly on physical devices. So if you're an embedded developer, I should be able to hook up my embedded device with a cable to a computer with whatever protocol my device supports, and I should be able to drive tests all the way down actually into that device. Let's say I'm doing Android development as an example. I should be able to have a test that will push across an Android ADB protocol to an actual device, run some tests, get the results back, and bring it back into that same framework. That same framework should be able to handle all sorts of things. Physical devices, web properties, traditional software that runs on a native computer, anything. I should be able to use the same framework to do all that. So dissecting that a little bit more, so that means I need to be able to do distributed execution. So I need an engine that can handle not only allocating all those things, but abstracting my rules. So when I say I want to run on something, I don't hard code an IP address or a host name. It's more of a request. Give me something that meets these parameters. Okay, the system goes out, figures out what it's got, brings it back, says, here's the one for you. Abstracted from product builds. It should be a multi-stage process where I can definitely, right after doing a product build, do a system test on it, but that should be something that the product build to use as an input to the test. So it's not tied to that particular version of the product. I can test and extend it to multiple versions of my product. So the big answer here is make sure that the harness can manage the resources and that there is an abstraction layer in the definition of what you're doing. So you're divorcing the build, test, function from the box. And try to use one box if you can. Try to be efficient and queue and see if you can share. If not, add more resources or have your software engine get more resources for you. Try not to lock things down. So we had a customer who was a mobile handset and network layer software company. They actually had a sophisticated test harness that controls the phone, just like I was saying. Their problem was developers, there was this gap between building the software and actually testing it on a device. They had to manually transport this image that was going to get flashed to the device to a physical test station. They would then have to flash the device and run the harness from there and sit there and actually watch the device to see the results come back. And there was some log file that came back that then they could copy over back to themselves so they could see what was going on. And so their solution was, and how we helped them, was to automatically push the CI build directly to the bank of test. Take out all those manual steps in between. And what that helped was, because they could now do that more frequently, they could spend more time on working on the test, less time on running the tests, and that kind of was a positive feedback loop that allowed them to reduce the number of failed builds they had, and when things went to manual testing, there was less that was dead on arrival because they'd done more automated testing than they could do before because it was so manual. Running the test harness. So here's what I want for this. So something has to run the harness. There's always, every time we have a layer of automation, then we think we've got it figured out. As I was showing in that maturity model, something else wants to come along and push the automation buttons and automate that as a bigger automation task. So I want to define the options and set up so it's in a central location. I really want one click with maybe a form to fill out with a couple of options, so I can just pick what matters to me and it should just go and do it. And when I say me, that me can be a QA engineer, it could be a developer trying to sanity check the last they're just done or about to check in. I want to be able to integrate multiple test frameworks into a single job. Maybe I want to do some Selenium testing and some server custom testing, and then I want to do a quick performance test. Maybe that's my smoke test. Any one of those tools oftentimes comes with some sort of automation in it, but there's nothing that ties together the many different types of testing you want to do in system test into one cohesive run and can drive multiple things and get one result back. I want security on it. So it's great to say that anybody can click it with one click, but we don't want to let that for everybody. So there has to be some fine-grained restrictions on, I want to be able to say who can do what, who can run the tests, who can author the tests, who can change the tests. I need a system that lets me control that. And I need to be able to customize the UI. Great that general framework is awesome, but I would like to be able to make a screen for end users that looks like something that they understand from my environment. I want to be able to make forms and screens and drop-downs and progressive disclosures on options. That it doesn't take me long to create, but makes it a lot easier for my end users to absorb. So the ingredients for this is I need a single place, I need it parameterized, and I need to be able to config. So the guidance here is definitely spend time in subsetting your tests. That's a good way to get started too if you haven't ever done this before. You want to subset your tests so that you can get started. Maybe that first subset is a very small test. Get started with a project that's achievable. Don't try to boil the ocean to start with. If you already have a lot of tests, make sure that you can subset them so people can run just what they want. Here at Electric Cloud, for instance, when someone works and wants to run automated tests, and we run millions of automated tests a year, you have a choice of saying, you know what, I know I just made changes to the agent platform. I don't want to run all the server automated tests. Now, we will always run that before we do a real software release because there's always things that people don't think A is going to affect B. It couldn't possibly affect B, and they're wrong, and there is some nuanced interaction. But when you're just trying to get through a development process and you're trying to complete a feature and you're just trying to get feedback and see where you are, remember, we're just measuring where are we, and have I made it better or worse, you should give people the chance to kind of opt out of certain tests. So subsetting is really important for that too. This last comment is just a piece of advice. A lot of customers are tempted to say that the whole test automation framework is a bunch of scripts and they live in the source code with the release, and we version them with the release. That's now tied it to one version of the release, to one product. You should maybe think, definitely version your tests, but maybe think of them as a product of their own. Think of them as the test automation framework is a test, and it is a superset and lives above all releases of your product. And definitely version it and back it up and make sure you can test old versions of your product. But it's a way of thinking of the test automation as a product itself that you're investing in, rather than just a little feature of the product. So a customer we had was a data warehouse provider who had actually pretty good smoke tests, had it figured out what they wanted to do. Their problem was more the handoff problem and the political problem. Development had to ask QA to do a smoke build test. And all the problems we were talking about earlier happened after that. It was manual resource scheduling, and their test resources were very expensive because it was very large machines to do these data warehouse tests. They had a monolithic, huge test script with endless options, but it was one big thing. And so what we help them with is really parameterizing their procedures. So in ElectricCommander, that's our product that does this. And it's very much like a programming language in itself, where you can have procedures that are parameterized, and instead of having one big script, you can decompose a big script, even if you already have one, into smaller components and wrap them into our procedures. And that helps break it down into more manageable chunks. And then using the framework, they were able to provide a one-click interface to run those procedures to anybody all over the world, any time of the day or night, without having to be logged in or SSH into a specific machine, or find out or try and coordinate with someone. Is someone else using that machine now? Is it right if I run my test? The system takes care of that. The system does the resource allocation so that it's safe to have other people run it, and you know you're not going to get in trouble. And they had been direct integration, so once they had that, developers could run it. Test reporting. This is the other challenge. So I've been shocked at our customer base, some of the customers who do really large software development, and even customers who do not such large projects, the amount of data that's coming out of their builds. Just gigabytes of log files, literally. And that's because all of us who are running tests and builds and all of that, we try to instrument the heck out of it with as much information as we can so that we can figure out when something went wrong, why it went wrong. So you're 99% usually of these log files is all the things that went right, and then you've got to dig for the one thing that went wrong. So if I've got gigabytes of log file, how do I find that error? And how do I automatically file a bug if errors are found? Do I have to go open up my defect tracking system once I find a bug and log that? Why shouldn't the system do that for me? If I have test results for specific builds, how do I map that to specific builds and see how it's changed over time? How can I watch a test automatic live as it executes? If it's running on one machine, great, I can sit there at the console. What if my test actually communicates with a bank of machines all working together as a system, components running on all the different machines? How am I going to monitor everything that's going on from one place? And afterwards, how can I get quickly to what I need to know? So results, really, the goal here is results need to be processed, automatically stored, and summarized. Here's an example. So out of ElectricCommander, if I showed you this, okay, hey, there's an error. What are you probably going to want to see next, right? Why shouldn't the system tell you, instead of just, hey, there was an error, or make you go through a log file to find the error, what should I do next? Now, we have a recommendation that as much as possible you should be generating this first message automatically by scanning log files. There should be known patterns in your log files that you're looking for. Kind of regular expressions, if you will. And our products have banks and banks of these that was shipped automatically for kind of typical software development tools and test tools. But there's no, as we know, a lot of customers have custom test harnesses, things like that. Log messages are very unique to them. It should be extensible. So you do all that. That's great automation, and it's absolutely a prerequisite. All of that to generate the, hey, here, dummy, there's an error. What do you want to see next? What you want to see next is something that has some context to that. I want to see a higher level of that. Okay, so I'm running a bunch of system tests, and which ones have passed and which ones have failed. Give me a name to the test, not just that some error happened. What was the name of that test? What was someone trying to accomplish? Okay, now I have a little more context of the order in which these tests are running, if that's important, the name of the test that's running, and perhaps I want to have an even higher summary that's linked in this case, with the whole build cycle, not just with the tests, mailed to me at the end of a run. And it says, here's a summary. There's 2,000 tests ran, and one of them had an error. Okay, that tells me something. Now I want to drill in, and I could drill into that previous level of detail, and from that previous level of detail I can drill down even further. What if I want to see a summary over 30 days of all of my branches, and how are the system tests running? Just kind of a good, medium, bad, right? That's something you might want to see. You might want to have a different display. These are just some examples that have more of a gauge of between 0 and 100. How am I doing on my performance tests? How am I doing on this, that, or the other thing? In order to do that, your test automation harness, I don't want to go into all the different kind of reports you can see, because you can do an infinite number of reports with pie charts and graph charts and all this kind of stuff. The key point is you can't do any of that if your test harness isn't instrumented to grab those little pieces of data, grab those metrics out of disparate test harnesses, bring them back into one system as data in a database that can then be queried to build all these graphs and all of these visualizations that you're going to want. So let's talk about where we got. So what do I ideally want from automated software test? I want scalable measurements. So I want to do a zillion different kind of measurements. Everyone's going to be different about which ones of that big list I showed that they're actually going to tackle. And I need it to be scalable, in my ideal world, infinitely. As many tests as I can write, you can run. As many people who wants to run them, you can run them. As many you want to do in parallel, you can run them in parallel. unblock the value of those tests by allowing them to run when they need to run. What we actually get, and this is really what our customers get and what we see in practice, is kind of pseudo-automation. Parts are automated. It's like close but no cigar, right? It's very frustrating to do a really good job automating 75% of something just to find out it's not really solving the problem, not useful because you weren't able to do the last 25%. We have this in our product all the time. We can have very complex problems solved in developing a product, but if you don't have that one feature a customer wants, they're still not going to buy. I'll use a car analogy. I'm sure there are engineers who would blow me away with the technical details of how they built the engine in a sports car. Yet when people walk onto the lot, they're looking at things like the leather, how does the steering wheel feel, how do I look in it, what's the cup holder, right? And the details behind what that engine engineering really is all about is lost. And as test engineers and developers, that can be frustrating. But it's the harsh reality. You have to do the whole job so that the end user experience is, I can push a button, I can really get everything I want, and I get the results back how I want, in order to satisfy the real need. Just automating part of it that needs a lot of manual intervention doesn't go far enough. Again, to repeat what we've said a couple of times, the three things are resource management, automation, and visibility. So a little bit of Electric Cloud. We have three products that help in this regard. We have automation with ElectricCommander as our product, which is the framework that automates the build process. It can do continuous integration. It can do all sorts of different types of builds. It automates the test process, integrating with multiple test harnesses, disparate things, doing things in parallel, controlling the resource management, helping manage resources, and visualizing things. We have the Electric Accelerator product, which for parts of the process, including tests in some cases, can vastly speed up the end-to-end run of what you're doing. Very important if you're trying to be agile and run more and more turns of the crank. You want things to go faster. The ElectricCommander automation framework also helps with speed because it can do things in parallel. An example of that, we were, of course, we use our own products. We had a custom script that was completely replaced by Commander once we built Commander here, and has been used for many years. And even though it had been used for many years, one of our new engineers took a look at it and said, you know, I see in our process we are compiling the code, running the unit tests, then running the system tests. Compiling the code, building the installer, running the unit test, then running the system test. And they said, okay, I get for the system tests that we need to have the installer built because we want to test the installer as part of the system test. We want it to be end-to-end. We want to actually silently install the product on a new resource and run it through its paces. But why are we waiting for the installer to finish to run our unit tests? Because unit tests just run off the raw code. They don't actually need the finished product. Can't we just run those two things in parallel? Oh, yeah, sure. We can save a lot of time doing that. Someone went into it, because they've instrumented this in our framework, and went to those two steps and checked checkboxes that said run in parallel. That was it. That's all you had to do. The system took care of now trying to find different resources to run that in parallel. And we saved a half hour on our build time on something that we already thought we were pretty good at, and this is kind of our gig here at Electric Cloud. And just by someone thinking about it and applying a little logic to what really needs to be done when. So parallelization at large levels can really help. Imagine that list of automated test frameworks I was talking about. What if I run my Selenium tests and my database tests and my load tests all in parallel? Does my system test now have to take 2 hours to run? Can I get the whole end-to-end thing down to 20 minutes if I have enough resources to run all those things in parallel? Well, how do I manage those resources? A tool should do that for you. How do I do that efficiently and cost-effective? Well, you use something like virtualization or cloud computing to provide enough resources so that you can run those things in parallel, and it doesn't cost any more than the physical resources you had before. So you just got to get creative. and use good tools, and you can solve these problems. This is a small subset of our customers, just to show, in case anyone was curious, we really cross all verticals. We have customers in embedded, in semiconductor, in networking, ISVs, web properties like Expedia, Facebook's a customer, PayPal, traditional ISVs, and really heavy industry. Folks, we were surprised. Folks like Caterpillar who build tractors, lots of software in tractors these days, GPS tracking, automatic field navigation systems, all sorts of things, very complicated software, and they're doing a lot of test of that. Every car that GM makes now built with electric cloud technology, including the Chevy Volt and all the new cars they're coming out with, the software layer is using electric cloud software. So that's just an example of some customers. Certainly be happy to talk to you more. If anyone is interested, we can do demos, online demos, deeper dives, ask questions, answer questions, whatever you like. Feel free to reach out for us either kind of passively by going to our website and checking it out, or send us an email and we'll have some obligation. You know, it doesn't have to be, it's not going to be a high pressure thing. Just call and say, hey, I got some questions. I did or didn't get what Martin was talking about on the webinar, and I'd like some clarification. We'd be happy to talk to you. So with that, that kind of concludes my prepared remarks. I think we will go to the Q&A session.
Great. Thanks, Martin. We do have a bunch of good questions that have already come in, and if you have any additional questions, go ahead and post them in the chat box below. So first question, someone was mentioning that they have a smaller shop, around 30 developers, and they want to know, does it still make sense for them to do automated testing?
Yeah, it's a great question. It's actually an ideal place to do it for two reasons. One, great to get that habit from the very beginning, because once you get everybody ingrained as you grow, and I'm confident that this customer is going to grow to be even bigger because they're going to be successful, you've set that stage. That's very much like us here. We are 50 software developers and QA engineers at Electric Cloud. We have hundreds of computers running, mostly virtual, but the instances that are running, hundreds of them running system tests every day. All our developers can kick off system tests. And someone just did a calculation, one of our guys in marketing did a calculation, and there was some enormous number of millions of automated tests run a year here, because we've got that culture of doing automated system tests. And when you're smaller, every person counts. Every hire is a big decision. It's a big financial decision. So what you're trying to do is save people time by using automation and equipment to do the things that can be done automatically, so that people can think about the harder problems. And so I think when you're smaller, it actually even makes more sense.
Great. So a question that just came in. Someone's asking, so the problem they had in their test automation was catching up with very frequent planned releases. And to add to that, test automation started very late in the project. Any suggestions on how to address that issue?
Yeah, so I guess my strategy there would be first concentrate on the parts that aren't changing very much. So trying to find regressions. You know, we innovate very quickly here. Every release has totally new features, and trying to keep up with that is always a challenge in automation. But there are some things, the base core architecture, that's not changing, and that's the kind of stuff we want that meter on, right? So has someone done something that's suddenly going to make exporting or importing or upgrades run 10 times slower? They did something in the code that broke that. So try and concentrate on the things that don't change very often, so you get the value, you can amortize that value across lots of versions, and then get yourself to where you're comfortable with that, and then you can spend your time attacking the new features. I think new feature development, rarely do we actually automate that here. So new feature development, because it's new, we're still figuring it out. Our QA organization, it's usually the QA engineer and the developer sitting down talking about it, going through all the scenarios, trying to figure out where the corner cases are. You can't automate something if you don't understand it yourself very well. And so with a new feature, we're going, particularly the first release that feature's out, we're going through that process of figuring it out ourselves. But if you've automated everything else, then those QA engineers have the time to manually look at the new stuff. So that's kind of our approach here, and that's worked pretty well.
Cool. Kind of a related question. Someone's asking about saying automating their testing is a goal that they're shooting for, but it's a big project. So what are the first couple of things we should do? In other words, what should be the priorities?
Yeah. I would make a chart if I was running that, and I would say, what are the areas that we're testing, and give it a score of 1 to 3 about the fit for that kind of testing to automation, and then make another column which is the difficulty you think in automating that task, and look and see if something jumps out, and just look for one thing. It's like when you have a new product and you're looking for the first customer that's going to buy your product. It's great to say on day one I'm going to have 1,000 customers for my product, but you're looking for that first lighthouse customer, and it's the same with test. I think you're looking for that first lighthouse test to say this is a perfect fit. It's going to be not too much effort to automate it, and it would be really nice to not have to do that manually. And it's 2% of our testing, fine. But in the process of doing that, you're going to get the harness in place, you're going to get the resource management in place, you're going to take care of a lot of the issues of automation so that when you go to add the next one, it's not nearly as hard, and you're not dealing as much with the framework as you are now thinking more about the test. So just, it's also like, my other analogy here is like writing a book. Just write something. Put the choice. You can try and be scientific about it, but it really doesn't matter. Just jump in and automate something, and then you'll figure out from there where to go.
All right, great. Well, several people are asking about the book that you mentioned earlier, and I know that was Dynamics of Software Development.
Let me go back to that slide and grab the name. So it's I can't read it. It's Jim McCarthy. I actually own this book. Development of Dynamics of Software Development, I think is the title. And you can get it on Amazon. And it's been around. He just had a new version of it, I believe. It's been updated in the last year or so.
Yeah, we put a link out on the browser there too. So if anyone
wants to
see, click on that link there and download from Amazon. So another question for you then. So we have some automated tests now, but it will be a struggle to convince management to invest in automating all of our testing. So how do they show them a payback for that investment? Yeah,
I think people are expensive. Even if you're doing offshoring, people are expensive. So what matters is, we have another slide deck we do in some other presentations. We talk about if you're going to automate something, really the payback is in how many times you're going to run that automation and how many human hours are you going to save. So if you're trying to talk to management, I would definitely approach it that way. And if it looks like $1 million upfront investment with lots of risk and it's going to take me a year to implement, even if you have an ROI that says at the end of that we're going to save $5 million in human costs, the problem with that is the risk and the time and the opportunity cost. So I would always try to attack this as I'm going to take a small problem and I'm going to show a payback in, this is something we run every release. We've been doing it for, N years or whatever the life of your product is. And every time we spend, and capture how much time you spend doing it and say, okay, the hard ROI is I can save that human time. I'm going to have to invest some time up front to automating it, but then I'm going to run that 1,000 times. And so that's 1,000 times a person doesn't have to run it. And then start to talk about the soft ROI, which is what could that person be doing when they're not doing this thing that could be automated? Go to your wish list, your defect tracking list. What's the backlog that you're not getting to? What if someone could get to that? Do you really have a nice white paper that tells your customers the performance characteristics of your product? Has someone in QA been able to do that what is really manual kind of boundary testing so that you can write it up and tell your customers, you need to size your servers or your product or your environment this way if you fit this environment. Find something like that that you've never been able to get to, and use it as an example and say, if we could offload some of this stuff and automate some of it, here's some of the other things that are important to you, management, that we keep having to tell you that we can't do, that we could get to. And as a manager, that plays to me when people come to me with that kind of an argument.
Alrighty. Well, a couple of people said they're new to automated testing, and they'd like a definition of the term you use, test harness, in the automated context.
Okay. So to me, a test harness, it is an ambiguous term. Let's look at a commercial tool. HP has a product called, from the Mercury division that they bought, called Quality Center. And it's a harness where you define your tests and you have all your inputs and outputs, and it kind of collects them. It can tie them back to requirements. You can kind of go as detailed as you want with it. There are many others from Rational and from IBM, from Silk, Segway. So there's some kind of packaged test harnesses that's their job. They try to provide an interface for you to define your tests and give you a place to push a button to run that test. What they don't do is decide when that button should be pushed in the greater life cycle, which is what we're talking about. And then the other is some of those test harnesses are really just Perl scripts. And we find a lot more of that in customers than the packaged apps. Definitely people are using the packaged apps, but it's a big old Perl script that I've written, and maybe part of that Perl script is FTP or SSH from some location where the bits are to some test server, run a silent install, passing in all the silent install options to get my software installed, then run it. Maybe kick off, set up a Selenium environment, get the Selenium server running and kick off some Selenium tests. So there are point tools like Selenium or this or that or the other, but the test harness is trying to encompass more of it, and typically that's either one giant Perl script or some sort of a packaged app. But honestly, people on the phone could probably argue with me and tell me that they've got something even different. That's why you need something that can span lots of different technologies and orchestrate it all together.
Alrighty, so another question from the audience. So how do I know whether my apps are good candidates for automation? This person has a number of application rewrites, and they don't have a regular release schedule after the new app has been deployed to production.
So I guess I would go back to my answer of the automation is worth it if you're going to run it a lot. So just because the software doesn't change doesn't mean you don't want to run the automation a lot. Maybe the environment around that app is changing. I want to test Windows 7 came out. I need to test my app on Windows 7. My app didn't change, but the environment I'm running in it changed. Or I want to make sure my system runs on network storage. How does the behavior change, right? Or there's some other parameter that changes, and you want to just be able to rerun a set of tests. If you're only going to do something once, it's clearly not worth automating. So you just have to look at how many times are you doing it manual. That's a good candidate to automate.
Perfect. So another person just asking a little bit about the product, and this asking, can you characterize the core features of your system in a few points that matter to users? Sure.
So let's talk about ElectricCommander, because that's the most applicable one here for test automation. First of all, it's a workflow engine. So you can define workflows at a very high level and say, I want this to happen and that to happen, and if this doesn't happen, then go back to that step, including visual flow charting out of that workflow so you can really see the process you've defined. Maybe for a test automation, it's first acquire 5 machines, then go get the bits, then go push them. If anything happens wrong in the mail, we'll send an email to XYZ. So it's a workflow engine. It's a parallel execution engine. It makes it very easy to run things in parallel on many different computers or devices at the same time and keep track of that and tie it all together so that one larger process. So customers typically are doing this with, like, I'm writing my own script and I'm R-shelling out to a bunch of machines, and when that machine changes, I got to go change the IP address of it. It's an authoring environment, so it lets you do set up some procedures, and you can even library them. So if I have common procedures and I want to reuse them, maybe have multiple teams or multiple products, and I don't want everybody to have to reinvent the wheel, allows you to library your workflows so that you can reuse them. Makes it more efficient when you have multiple people trying to do similar things. It has great scalability. You can run thousands of things concurrently on the automation server, as well as great security. So you can very fine-grained decide who can see, change, or run anything. So let's say you have two teams and they're both doing test automation, and they can both be running off the same server and not even know the other one exists, because with security you just hide the workflows from each other that they're not allowed to see. I can enable developers to run tests, but I don't quite trust them to author the test or change them. Only the QA group owns that. So the security is a big part of it. And then the resource management, being able to have integrations with physical, virtual, and cloud to do either static things. I have 20 machines, and I want your system, ElectricCommander, to manage who gets to use what machine when, make it exclusive access to a test while it's running, give it back to the pool when it's not running. So kind of being the marshaller of resources in a static environment. Even cooler if you have a dynamic environment with virtualization or cloud, be able to say, I need 3 machines spooled up and run right now that meet this particular configuration, and then now go point my test at it, and then when I'm done, tear them down to really use your resources efficiently. So those are, in a nutshell, some of the key benefits.
All righty. Well, some people are talking about products that are still under development and want to know, how does automated testing fit in there? Saying their UI automation would break, for example, because every new build would come out after there are more UI changes, and by the time the tests are fixed, a new build will be available, et cetera. So does it make sense to automate on a product whose UI is continuously changing? And maybe how do some people do that?
Yeah, so certainly the back end, the question was about UI, but certainly there's no reason the server side of that couldn't be automated and tested. So whatever the UI is using to connect to the server, if it's, let's say you have a GWT application using servlets or something like that, there's no reason to not test the server side and the inputs and outputs of the server to make sure it's still doing what you expected. And for the UI, if the UI is really in flux, you're making major changes to screen layouts and fields and progressions, yeah, let that settle down before you're going to try and automate it. But the ones that have settled down, make sure those are automated, because you want, particularly as UI frameworks have become more complicated, and it's not just, for let's say a web application or not. Well, let's just pick a web application. It's not so much isolated pages anymore. People are making much more complicated, with Ajax and integrations, web applications, not just web pages. And so what can happen in that is you think you've settled and fixed one page, but it's really including some common UI library code. Someone changes that UI library code, there's nobody looking at the other page because you think it's done. You're all working, you made the change to try and fix up the new page you're working on. You want some automation to go, whoa, look out, that other page changed. So as soon as something is firm as Jello, I guess, I would try and make an automated test for it. Here at Electric Cloud, we have a mantra. You are not done. You can't say you are done with a feature until the automated tests are complete also. That's just part of the process. And that includes UI screens. If you have a new UI screen, when you check it in and you tell the development manager, I'm done, I'm ready for my next task, if you haven't done the automated tests, they're going to say, you're not done, go back and finish that. Because if you don't do that, you get behind. But while I'm in the middle of developing that screen, I'm not going to automate the test. I'm going to wait for it to firm up a little.
Gotcha. So then kind of a follow-up to that, where do you think people should start? This person is saying they're in a 100% manual shop with both UI and back-end testing to do. So should they start on the UI or start on the back-end? I
would actually start on the back-end for 2 reasons. One, because as we just discussed, it is a little bit easier to automate. And number 2, usually the UI gets more eyes on it and it's easier to test if it's working or not, whereas subtleties in the back-end are harder to find. Certainly with UIs you have performance issues and you have response times you want to measure also, not just from the server side. But if I had to start somewhere, I would start with the server because the server makes the contract for the UI. Make sure that's working as I wanted. Because if you start with the UI, the question is, well, it didn't work. Is that because it made a request to the server and the server gave me back garbage? Or is it because I have an error in my UI code? So I would start with the lower layer stuff first and then work my way up.
All righty. Well, we're run over our time here already, and I don't want to take up too much more people's time. But anyone who has submitted a question that we didn't get to, don't worry, we'll follow up with you by email right after the presentation. But any last thoughts, Martin, for our viewers before we let you go?
No, other than just if you're not doing test automation, don't be afraid of it. Try something. You will be pleased with what happens. It is worth the investment. Whether you use our product or not, do automated testing.
Sure. All right. Well, thanks again for joining us. It's been a great presentation, and thanks to everyone else who participated in putting this show on today. Thanks again, Martin, for joining me today.
Thank you, Patrick.
And if you would like to know more about ElectricCloud, you can visit them on the web at electriccloud.com or electric-cloud.com. And if you'd like to view this webcast again or recommend it to a friend, just come back to the same link you used today, and the recording will be up by tomorrow about this time. Also, if you'd like to view any other webcasts in this series, just come back to agilejournal.com/webcasts. I look forward to seeing you all on our next presentation. Bye-bye, everyone.